All right, so here are my project pseudocodes. This is like take number 4, it's 11:20, let's get this done. So part B. So I start out by, this is the multiplying matrices question, naturally. And I don't know so I set up a few arrays and some variables in order to utilize, set up my matrix, my matrices I'll be using and the row and column numbers I'll be utilizing. So I have the user define our row and column number of matrix A and B with a simple print and scan combo. And then I set a timer, and that's supposed to count up through all the elements in either matrix. You're prompted to do A and then B. And from there, I set up a while condition because if the number of columns in matrix A, I don't know why I wrote first and second, is not equal to the number of rows in matrix B, then you're not allowed to continue, and it resets you back to entering the row and column number so that it can get a proper amount, and it proceeds to do the math for you effectively. As I set up the function multiply matrices, it's got everything included. It sets up a counter and sets up the multiplication, and then it sets up like the cross product is kind of the idea here. It's a little sloppy, but basically the arrays go through each element and properly set up the like the cross product or the dot product, I believe it is. And there you go. Here's your result, print, and then yeah. So that's pretty much the if j is equal to column minus 1 is kind of an idea of how you like loop it, but yeah, kind of got all the important stuff there. So then D, you start off, enter in the values of matrix A and B, and I realized that, we're using a 3x3 matrix, and matrix A will always be 3x3 and matrix B will always be 1x3 is the idea. So you just enter in the 9 values of A and the 3 values of B, and then I set up, like, this is supposed to be my function to do determinant. I forgot to put in my variables there, but basically the idea is that to find our first determinant, the one that's crucial to Cramer's rule, is set up that function, and if that ends up bringing back a 0, I should have had it returned. I should have written down like return value there or something like that. But basically, if the value is 0 and D turns out to be, and I forgot to set determinant equal to D. I kind of spent a lot of time on the first one. I kind of rushed through this one. I was also really confused by Cramer's for a minute there. But yeah, it basically, if D equals 0, there are either 0 solutions or a near infinite number of solutions. We're done here. And then from there, so what I need to do next is create the 3 matrices so that I can find their determinants. The 3 matrices being the ones that replace matrix B in the first column, second column, and third column, respective to X, Y, and Z. And what I'm thinking is I kind of ran out of time, and I had a lot of frustration, which I know I'm sure you've heard that a million times, so cry you a river, I know. But the point being is, shoulda, woulda, coulda is basically what I'm saying here. Like, I think I should change my inputs to 4 different arrays instead of having like all these listed here. Sorry, I'd be shifting so close to the screen. Having all these listed here, I could simply just have them as arrays, and that way when I'm doing trying to swap out the values to calculate the determinants, it'd be way easier to set that arithmetic up. I could probably just set up like a counter at that. It's very similar to the last problem. Really, just go through the matrices, and less about going through them and more about how to go through them, like what, and maybe even just setting the counter to do B, or in this case D, the D values, in place of A, or in place of B, or in place of C. I just gotta figure out how to set up that loop. If loop's really that's a loop. You're looping through the information, so. Okay, 15 seconds off. So, and then, from there it's just simple math, Our value of determinant of X should be just our determinant function utilized on our swapped out matrices. And then from there, it's just a matter of, to get our values of x, y, and z, just, you do your determinants you just found with the three individual matrices and divide those all by our value of d we found. That cannot be 0, or else we would have been done by now. And, the value just tells you there, your values of x should be bam, bam, and x should be that, y that, and z that. And, and I mean, well, yeah, you saw. All there is get char and return. So, yep. All right. Time to upload this and finish off this last slide. Thank you.